Hey everybody, still in basic geometry concept. If you have not realized, there are a lot of basics to geometry. I'm on slide 15, which is talking about perpendicular lines. Perpendicular is a word you're going to hear me say a lot this semester. It basically means that you have something that forms a 90-degree angle, like a right triangle. We call that a right triangle because one of the angles is 90 degrees, and that makes those two segments perpendicular. So we're going to click on GeoGebra. Oh, okay, look at this figure. So we've got a couple things going on already. Looks like two parallel lines. Lines that are parallel will not intersect. You've got a transversal. Basically, a transversal is a line that intersects two lines, usually parallel. They don't have to be. But I know they're parallel because, look, I got some 90-degree angles. These are perpendicular. So this line BG is perpendicular to the first line, and looks like also BG, or you're going to call it BE, is perpendicular to CE or CD or ED or CD, however you want to name it. You name it by 2 points, right? So you want to name it by any 2 points that make up that line. All right, let's see what's going on here. I have two perpendiculars. All right. So move point B to different locations in the coordinate plane. What do you notice about the relationship between BG and GF? BG is this one. GF, well, I don't see an F. Oh, there's an F. So we're looking for the relationship between BG and this line GF. And again, I'm going to move point P to a different location. All right, so I'm going to come up here. I'm going to click on Move. I'm going to grab B. I'm going to move it. Well, it looks to me like that angle doesn't change. It's going to be 90 degrees no matter what. I don't care where I move that sucker. It is 90 degrees. It never changes. Looking right there. So move it over to the left, still 90 degrees. Move it over to the right. If I even get B closer or further away, the sucker stays 90 degrees, so it remains perpendicular. The angle remains perpendicular. Yep, always 90. Boom, go me. All right, question 2 says move point B some more. As you move point B, the angle formed between AB and CD varies. So AB, where's AB? AB was just this line, because there's A and B. CD, all right, so again, I'm looking at this angle. Well, it looks like this one does change. It definitely varies. So I'm just trying to get it back to 90, which is going to be incredibly difficult to do. Unless I have a steady hand. There's 90.1, pretty darn close, but not exactly the same. All right, so if you want to make AB perpendicular to CD, what do you need to do? Explain in terms of BEC. Well, I've got to move point B until angle BEC is 90 degrees again. And that's it. Yeah, so just make sure it goes back to being 90 to be perpendicular. All right, so question 3. Describe the relationship between GF and CD when the two lines are perpendicular. Well, I've already told you guys this answer. When they're both perpendicular, then these two lines are going to be parallel. When they are both perpendicular to AB, then the lines are parallel to each other. All right, so also describe the relationship between GF and CD when CD is not perpendicular to AB. All right, so, well, when CD is not perpendicular to AB, the lines will eventually intersect because they are not parallel. That just makes sense, right? I mean, if you're sitting here looking at it, go back to the original. All right, so there's my original. That's what it was. So I have a 90-degree angle for the first one and 90-degree angles for the second one. That makes them parallel. If for some reason I move it, they're not parallel anymore. Eventually they're going to intersect each other. So if I move it over there, well, there's your intersection right there. Just common sense, you guys. Oh, self-evaluation. Go me for knowing what I'm doing. So hit submit. All right, cool.